So let's wrap up. Model-based system engineering is system engineering. Fundamentally, it's just a better way to do system engineering to deal with the complexity that systems have today with all the software, the data, the interconnectivity. It's just the way we have to do system engineering going forward. It contrasts with the more document-based approach, and you can see that you just can't scale when you have all this data distributed across different documents that aren't truly connected together, and data is described differently in the different documents. It's difficult to maintain and synchronize. So the notion of having a cohesive system model is just going to be essential to moving forward in the practice of system engineering. This system model is a primary artifact of the SE process. It's not something that's developed out here. You develop it as you go through the specification and design process. It's part of the way you do system engineering. And it provides that shared view of the system and all the other benefits that we talked about to help us manage complexity and risk. To get the full benefit, we need to integrate and manage this system model with other engineering models as part of that technical baseline, that authoritative source of truth that evolves from conceptual design across the life cycle, both from system to system level all the way down to component level. That's where we're trying to go. We're not really there yet, but that's where we're trying to achieve. To finish up, you've learned in this class, you've got introduced to the why and what of MBSE. Why do we do it and what is it? But learning to model is a commitment on your part, on your organization's part, in time and resources. And it really does require an understanding of the modeling language in depth. It requires an understanding of the modeling methods that you're going to use and of the tools. And you really need to grasp all of those. So this is what will take time and commitment to develop your expertise in model-based system engineering approach. This clearly is on top of being a good system engineer, where you have the skills, the basic system engineering fundamentals, you understand them well, and that you have the domain knowledge in whatever domain you're working at, aircraft, command and control, automobiles, telescopes, whatever it is. These modeling skills sit on top of your foundational skills as a system engineer. And if you can develop those skills, you can be a real contributor to programs and projects in the future. So with that, that completes part one of this introduction to MBSE with SysML. And we will go on to the second part, which is an example of how you use SysML to model a simple system. So thank you.